All right, suppose that we have this rule, the integral from 1 to 3 of fx dx is 1. We want to find the integral from 6 to 6 fx dx, and we want to find the integral from 3 to 1. So kind of two things going on here. This is requiring us to remember some rules about our integrals, and if you wrote them down or if you have your notes page handy or whatever, dig it up. If you don't remember, one of the rules that we learned was if we have an integral, say from a to b of fx dx, okay, and not just from a to b, but let's say it was from a to a of fx dx, then we would say that this has no value. It's 0. Why? Because integrals determine area under curves. And if I have no area because I start and stop at the same place and don't move to create any shape at all with area, then I have 0 area. So if we look at the integral from 6 to 6 of fx dx, that is a carbon copy of this rule of integration. That's a big old fat 0. Now let's look at the other guy. One of the other rules that we had was if we integrate from a to b of fx dx, one of our rules said these are equal. I can put a minus sign out in front, and I could change my upper and lower limits to go the other way. Well, looky here. This guy is a carbon copy of this guy, but with numbers backwards. So my 3 to 1 fx dx becomes negative 1 to 3 fx dx. And hey, gee willikers and gosh gollies, we got a rule for that one, and it is 1. So my answer in this particular case is going to be negative 1. And that's just using some of your basic rules of integration. Okay, more practicing rules of integrals. So I'm being told that one integral, f of x, goes from 3 to 7 and is equal to negative 2. And the second integral goes from 3 to 7 and it's g of x and it equals 8. So find from 3 to 7 4fx gx. And basically what we're saying is if I have two integrals that use the same limits, upper and lower limits from 3 to 7, then I can actually add those two integrals together and discover the total space. This problem goes one step further and it adds a little 4 there. So let's just break this up real quick. I'm going to have the integral from 3 to 7 of 4fx dx plus the integral from 3 to 7 of gx dx. And here's the thing. I know gx dx because I was given that as one of my rules. So I know that this guy over here is going to equal 8. Okay. The thing I don't know is this 4fx dx. Well, I had a rule that said if I've got some function from a to b, or some integral from a to b, and I've got a constant times a function, then I could pull the constant out and it would be the constant times the integral, and I would leave the function in there. So it would look like this, okay? Well, look over here what the problem that we're working with. I can pull the 4 out, and I have the function from 3 to 7, or the integral from 3 to 7, times, not times, gee willikers. I've got 4 times the integral from 3 to 7 of fx dx, plus this 8 over here, which satisfies the g of x integral. Well, the integral from 3 to 7 of fx dx is negative 2. So basically what I'm working is 4 times negative 2 plus 8. And negative 8 plus 8 is a big ol' 0. And so even though this one equals 0, they don't all equal 0. This one just happens to turn out this way, but it really is no more difficult than 4, some constant, times whatever your function is, and then just adding up all the little integrals together. All right, 21 says find the average value of the function without integrating. by using geometry. So I've got a triangle shape here. And in order to find the area of this triangle, I need to figure out what is going on. I need a base and a height, okay? Well, my base runs from -8 to 6. That's my base, okay? No problem there. I'm doing 8 plus 6, so my base is 14. I need to figure out the height, and the height occurs right here at -1. That's where my function changes a little bit. So I just need to figure out what that value at -1 is. We're going to stick -1 in for x. We're going to add 8, and we're going to get 7. Okay, so this guy is 7 right here, which means that my height is 7. All right. Now, average value, I'll write it down. Average value is 1 divided by your upper and lower limits of integration times the integral fx dx. Okay, that's all there is to it. Well, this part right here, this part is area under the curve. Well, we've got a triangle, we've got base and height, we can find that area. I know that A and B are going to be -8 and 6, so I can kind of sort of start working on this. I'm going to have B, which is 6, minus -8 times, so let's just figure it out. Down here, 1/2 the base times the height, or 7 times 7, or 49. So this is going to be 49 over 1. All right. And now just multiply this guy out. This is going to end up being 49 over 14, which is the same thing as 7 over 2. And both of these answers would be correct. 49 over 14 and 7 over 2 would be correct. Okay. But again, average value, it's 1 divided by how wide your base is times the area under the curve.